Okay, this type of problem is a favorite problem that first year general chemistry students will most likely get. It's a favorite problem to be asked by a professor. Silver occurs in nature as a mixture of two isotopes. 107 Ag has an atomic mass of 106.906 AMU, atomic mass units, and 109 Ag, which has an atomic mass of 108.905 AMU. The atomic weight of silver is 107.868. What is the percent abundance of each of the two isotopes? Okay, the first thing that we have to do here is we have to assign what the values of these particular things are. So we know that atomic weight is going to be equal to the atomic weight of element A times the percent of A plus the atomic weight of B times the percent of B, and so forth and so on. In this particular instance, we have to set what the values are going to be. So we're going to say let x equals percent of one element, and then we'll say let 1 minus x equals percent of other element. Now, we don't know what these percentages are. So what we do have is we know what the atomic weights are. So we have 107.868, which is what we were given as the average atomic weight, is going to be equal to 106.906. We don't know what the percent of this here is, so we can say 1 minus x for the other element plus 108.905 times the percentage of the other element. Now, what's key here to remember is that whichever percentage that you assign, whether one element is x and the other element is 1 minus x, it really doesn't matter. I could have easily said that this here is x and this here is 1 minus x. You will get the same exact answer. So it doesn't matter. What's important to do is to make sure that you keep your elements straight as opposed to doing 107 minus x or 107 minus 1x, that you keep the numbers together. But in terms of which one gets assigned 1 minus x or x, it doesn't really matter. So once we do that, we'll do our math. We'll have 107.868 is equal to, we're going to have 106.906 minus 106.906 times x plus 108.905 times x. We subtract and we add our like terms together. So 107.868 minus 106.906 equals a negative 106.906x plus 108.905x. This term here is equal to 0.962, which is equal to 1.945x. Solve for x. X is going to be equal to 1.945, divide both sides. That's 1. So we have x equal to 0.4946. So if x is equal to 0.946, our other thing is to find out what 1 minus x would be. So if this is 49.46, you know that this number represents 49.46% of the element, whichever x is, and the other one is going to be 1 minus x, which is going to be 1 minus the 0.4946, which is equal to 0.5054, which translates into 50.54%. So one element is represented by 50.54%. The other element is 49.46%. So this here is AG 109. Let me see. AG 109 would be equal to 49.46%. 49.46%. While AG 108 would be equal to 50.54%.